So when we look at a line represented with vectors, we're going to take the center of the universe, which is 0, 0, 0. That's the point. And we're going to go to a point on the line. This is what we call vector A. And that vector gets us to the line. And then we're going to have a direction vector, direction B. And it can be any number of unit vectors to get to the point. Let's say we want to go to point P. So we have vector A and so many steps B, and I call this is a scalar number of steps. With this combination, I can get any point along that line from the frame of reference. And this is how we're going to represent a line. And then eventually we're going to represent a plane, but not yet. Okay, so for the line, we're going to primarily write it in vector form. X, Y, Z, this is my point on line. And then this is going to be my direction vector. And this is going to be the number of steps. What's that? Yeah. Yep, it's the number of, I call it the number of steps, or you can call it unit vectors. Now here's where it gets interesting, is that once you have these, now what you're going to want to do is you're going to want to turn this into a different form that's a little bit more usable. One form is the parametric form, which we've looked at, your favorite part of calculus, right? X equals x1 plus lambda a. Then we can say y equals y1 plus lambda b. And z equals z1 plus lambda c. Lambda is the number of steps. Yeah. Oh, yeah. Yeah, there's lots of connections. And then what we might like to do is we might like to, we like x, x1 and a, b, c, and all that. We don't like lambda so much. So what we could do is we could solve x minus x1 equal lambda times a. And if we divide by a, you're going to get lambda equal to x minus x1 over a. We can do the same thing. Y minus y1 is equal to lambda times b and divide by b. Then we could take z minus z1 and set that equal to lambda times c and divide by c. And what is true about the number of steps lambda? They're equal to each other, right? So then, since lambda equals lambda, we can say that x minus x1 over a equals y minus y1 over b equals z minus z1 over c. This is the Cartesian form because this is what we usually are trying to get to. No lambda in the Cartesian form. Parametric and vectors, we will. Does this look familiar? Do you remember these? Yeah. Yeah, this is where it got kind of interesting. So we're going to change this into Cartesian form. So I'm going to start by x, y, z. I'll give you a chance to write that down. What is this part right here? What does that represent? Position vector. It's the point on the line. It's from the center of the universe, Allison, to a point on the line. And so this point on the line is 3, 1, negative 2. Is that part okay? And then we're going to have lambda, and the direction vector that I'm stepping or moving will be 1, negative 4, 1. And that's what I like to call the vector form. All laid out. This is in the position form. This is the column vector form, would be more accurate. So just moving across, x equal to 3 plus lambda, y equal to 1 minus 4 lambda, and then z equal negative 2 plus lambda. And then if you wanted to solve for lambda, you're just going to get x minus 3 equals lambda. Here you're going to get y minus 1 over negative 4 equal lambda. And then you're going to get z plus 2 equal lambda. So then if the lambdas are equal to each other, then you can just go x minus 3 equals, if you don't mind, I'm going to go 1 minus y over 4, just to make it look a little less awkward, equal to z plus 2. So this is my Cartesian form, no lambda. And then this is going to be my parametric form. And we're good to go. How many got those? Easy. So that's something you're going to do. You did this already. Just a couple of little things. This is a parametric form. We can write this as a vector equation. The way we do that is xy equals 4, 5 plus t, and this will be 5, negative 2. Okay. The speed is a little tricky. Would you highlight this vector? This made no sense to me until I put on my physics hat. How many of you like physics? Good people. All right, so here's distance, right? This is a point representing distance. This is a point representing distance. What does this quantity have to represent in order to have distance plus something equal distance? What does this have to be? Distance has to be. It won't work unless it's distance. Okay, so time times what is distance? Velocity. See, this t times, what does this represent? It has to represent velocity because velocity times time is distance. So it always bugged me until I thought about that. Okay, so all you have to do is take the magnitude of v is going to be the square root of 5 squared plus negative 2 squared. I think that's a little out there. Maybe it makes sense now, I hope. But that's the speed. Um, 1 minus 2 squared, what's that? Oh, I'm sorry. This is a parenthesis here. Is that okay? All right. So we got the vector equation. This is part A. We got the speed, part B. Now, will the object hit the car or not? Well, what should happen for t in order for these to connect? They should be equal. So what we're going to do in part C is this is the position of the car, which they're saying is 19 and negative 1. So if 19 equals 4 plus 5t, then 19 minus 4 is 15. What should t should take how many seconds for the x's to connect? 3, right? Take your hands like this. Go like this. Okay, that would be a collision. We could have the right hand sooner or the left hand sooner, and therefore there's 3 possibilities that could take place. We want to see, though, if they are going to strike, then my second one, negative 5, or negative 1, should be equal to 5 minus 2t, And if this is going to work, you're going to subtract 5. Negative 6 equals negative 2t. What's t going to be equal to? Negative 6 over negative 2? 3. So since those are the same, they are not going to arrive at different times. They're going to arrive at the same time. Is that okay? All right. I think you got that. That shouldn't work. Okay, so what are 4 conditions for 2 lines in 3 dimensions? Turn to your neighbor and tell me 4 things that can happen. You guys are incredible. You're thinking like me. That was the first one I had. Intersect. Tell me another. Parallel. No way is that number 2. Very nice. So they could intersect. They could be parallel. What's another thing they could do? Oh, you didn't get that one. It's okay. You got that one? Nice. They could be the same line. So parallel is different than the same line. We would say parallel, yeah, they have the same slope, but they're being the same line is a little different. And then if it isn't, you're skewed. So that means they're like this. If you look at 2 lines, though, in a shadow, it looks like they intersect, right? And so from one point of view, they will look like they intersect, but if you look at it in 3D, they do not. And that's going to present a challenge for us that we're going to be looking at. For tomorrow, you're getting into some reading situations, very similar to what you'll be doing with the IB test. Find the vector form of the line passing through this point and this vector. I bet you're going to do great with that. You're going to go x, y, z is equal to, what's the point? I always like saying that. Plus lambda, what's the direction? 1, negative 2, 3. Done. There you go. And they just wanted you to know the vector form or the column vector form. You could do other forms as well. Go to number 4, please. Find the Cartesian equation of the line passing through the points A and B. Provide the parametric. We're going to start with actually the vector form. So here are my 2 points, A, which is 5, 2, 6, and B, which is negative 2, 4, 2. I'm doing this methodically for a reason. All right, let's make the vector form x, y, z. What do you want to use for a point? Really, what do you want to use for a point? A or B? Good choice. But both are fine. You could use either one. But Kaylee's right. A is the cuter of the 2. Now, the only thing you're going to mess up, possibly, is finding the direction vector. The direction vector normally is going to be A, B. So, if I'm looking for vector A, B, do I take B minus A or A minus B? B minus A, because it's head minus tail. So would you write head minus tail? Or in this case, it's B minus A. Just write yourself a note. That is something that students get wrong. You're not going to on the test, though, because you're going to remember that. All right, so B minus A is negative 2 minus 5 is negative 7. And then 4 minus 2 is 2. And 2 minus 6 is negative 4. Now I have my direction. Now the good news is, for this problem, if you did it wrong, your lambda would just be the opposite. But it's okay. We're going to try to be consistent. Then can you go the rest of the way? Figure it out? Okay. Now, who likes shortcuts? I love shortcuts. Do the way that I showed you, but if you want to skip right to the answer, this is really kind of cool. What you do is you go x minus the point, y minus the point, z minus the point. The point is 5, 2, 6. 5, 2, 6. It's literally that easy. And then the direction vector tells you what the denominators are. -7, 2, and -4. When you do if you do that one the rest of the way, you're going to see that that's the answer. Now, granted, you might see it, 5 minus x over 7 and 6 minus z over 4. That's probably what you're going to see. But I just wanted to give you a heads up on that. And I think that's kind of fun. So you do those. Yep. And here's one. You're going to show that these are parallel. And you're going to find the equation. There's 2 of them here. 2 points, 2 points. And find the angle between these two. Great reviews. And that's it.